And the final test we're going to look at is, again, another sophisticated test, the dielectric discharge test. Now this one is fully pre-programmed, so there's no setup to do. It's just a matter of a selector switch position, again, your test voltage and your test button, and the operator then steps aside, and this one is a very long test. It runs for 30 minutes, so you can schedule some other work to do while this is in operation. This test is developed by the French utility for the specific purpose of detecting problems very difficult to identify with other test methods. And where they found it particularly useful was multi-layered insulation where a particular layer has deteriorated but at the same time is surrounded by perfectly good layers. Now, in all the tests that we've looked at so far, the tester has applied an active voltage and it's pulled leakage current and measured it. At the end of any of those tests that we've looked at so far, when the test voltage ceases, the tester automatically discharges the static voltage on the test item. Now, in all the other tests, this is a safety function, so that there is no static voltage left on the test item that could injure someone that came in contact with the test item. And the tester discharges that and monitors it, and you can watch that on the display. When you're doing the dielectric discharge test, you're now actually incorporating the discharge current into the evaluation of the test. So what happens is, test runs for 30 minutes. The idea behind that is almost all test equipment is going to be pretty close to full charge at the end of 30 minutes. At that point, the test voltage shuts off. We no longer have an applied test voltage, but the tester now begins to measure what is sometimes called relaxation current, which is that all the current stored on the test item is now going to try to relax and return to its original state in the absence of applied voltage. The tester waits a minute so that the capacitive current, which is of no concern, has been discharged, and then it looks and measures how much leakage current, what we call reabsorption current actually, is still flowing. And this is the current that's been stored in the insulating material. And at the end of the test, it calculates again a figure of merit like you get with the polarization index test, except the numbers are the reverse. Now you want low numbers. A good number is 1. And the higher, the worse it is. And the interpretation of it is then that on multi-layered insulation, the charge should be stored pretty much equally across the body of the insulation, and a deteriorated layer will distort the spread of charge, and this will be reflected then in the amount of discharge current, and it's automatically calculated by the tester into the figure of merit that is displayed. So again, as with the other tests, all your relevant data is shown at the end of the test, and the dielectric discharge ratio is calculated for you and shown on the display for the operator's interpretation.